Activity 1. Printing text in serial monitor. In this activity, we learned how to display text using the serial monitor of the Arduino IDE. It was easy because we just needed to connect the Arduino Uno to the computer using a USB cable. Our only challenge was finding the magnifying glass icon that opens the serial monitor, but we quickly figured it out. This feature is useful for testing and debugging Arduino programs by showing messages or data outputs. Activity 2. Showing temperature readings. In this task, we explored how to use a temperature sensor with the Arduino. The temperature readings were shown in degrees Celsius on the serial monitor. It was quite simple, although we had to ensure the correct pin connections for accurate readings. This setup can be applied in temperature monitoring systems such as thermostats and weather stations. Activity 3. Checking if the button is pressed. This activity allows us to detect button input using the Arduino. We connected a push button, and when it was pressed, the serial monitor display button pressed. The only challenge was ensuring proper wiring to avoid false readings. This concept is useful in control systems and digital devices that use button-based input. Activity 4. Serial monitor as remote control. In this exercise, we learned to control an LED using commands typed in the serial monitor. Typing 1, turn the LED on, while typing 0, turn it off. We had difficulty at first because the LED didn't light up, but after replacing it with a working one, the circuit functioned perfectly. This activity demonstrates how manual commands can control devices remotely. It is useful in home automation systems. Light sensor logging. For this activity, we use a light sensor to measure brightness levels displayed on the serial monitor. We found it easy and fun, especially when we use our phone flashlight to change the reading. This component can be applied in automatic lighting system, smart lamps, and brightness control technologies.
Activity 1. Distance Measurement Display, Version 1. In this experiment, we use an ultrasonic sensor to measure distance and display it on the serial monitor. The setup was easy, but we had to carefully connect the trigger and echo pins. This technology is commonly used in distance measurement and object detection systems such as parking sensors. Activity 2. Distance Measurement Display, Version 2. This activity enhanced our previous setup by displaying distance on the LCD screen instead of serial monitor. At first, the LCD did not display properly, but after checking the wiring and code, it worked fine. This kind of setup can be applied in digital rulers, measuring devices, and car parking systems. Activity 3. Obstacle Detector. In this task, we created a simple obstacle detection system using the ultrasonic sensor and an LED. When an object was detected nearby, the LED turned on. It worked smoothly after ensuring the sensor was properly aligned. This can be applied in security alarms, automatic doors, and robotics. Activity 4. Parking Assistance System. This was one of the most challenging but rewarding activities. We used 3 different colors of LEDs, which are green, yellow, and red, and a buzzer to indicate safe, caution, and danger distances. We struggled with the many wires, but after organizing them carefully, everything worked perfectly. This system can be applied in car parking assistance and collision warning devices.
Dapat may
Activity 1. Black and White Detector. In this activity, we use an infrared sensor to detect black and white surfaces. It was easy to perform and the sensor accurately detected dark and light colors. This principle is applied in line following robots. Activity 2. Proximity Triggered Sensor. This experiment helped us understand how proximity detection works. We connected an LED and buzzer that activated when the sensor detected a hand. The challenge was that the buzzer didn't sound at first, but after fixing the wiring, it worked properly. This can be used in automatic doors, safety sensors, and touchless systems. Activity 3. Count the passers. In this activity, we created a counting system using an AR sensor and an LCD display. Every time an object passed by, the counter increased by 1. We initially faced display problems, but we solved them by rechecking the connection. This can be applied in entrance monitoring systems and people counters.
Activity 1. Button Control DC Motor. In this task, we control the DC motor using a push button and a MOSFET. The motor started when the button was pressed and stopped when released. It didn't work at first due to incorrect wiring, but after troubleshooting, it ran perfectly. This application is used in machines, fans, and automation projects. Activity 2. DC motor speed control using potentiometer and MOSFET. Here, we learned how to control motor speed using a potentiometer. Turning the knob increased or decreased the motor speed smoothly. It was a simple yet effective in showing how analog inputs affect speed.
Hi vlog! For today's video, we're going to the lab.
You do the H-Bridge activity.
So come on, let's go!
Activity 1. Motor Power Control. In this experiment, we use an H-bridge to turn a DC motor on and off in intervals. We struggled a bit because some wires were loose, but after securing them, the motor worked fine. This is used in robotics and automated motor systems. Activity 2. Motor Speed Control. This activity allowed the Arduino to automatically control the motor speeds by connecting EN2 to pin 9. It was easy after following the correct wiring diagram. This is useful in smart machines that require adjustable motor speed.
Lesson 3. Motor Direction Control. In this activity, we made a DC motor rotate clockwise and counterclockwise using Arduino pins. It was easy, but we needed to double check the wiring. This can be applied in a robotics arm, elevators, and conveyor system.
Lesson 4. Push button motor direction control. We added 2 push buttons to control the motor's direction, one for forward and one for reverse. We had to make sure the buttons were properly connected to work correctly. This design is applied in remote-controlled vehicles and machinery.
Activity 5. Motor Direction and Speed Control using push buttons and potentiometer. This final activity combined both direction and speed control. We used 2 buttons to change direction and a potentiometer to adjust speed. We encountered code errors at first but fixed them using AI assistance. This type of system is applied in robotics, automation, and motor-driven equipment.
Our robotics activities, we learned how to use the Arduino with different components like LEDs, buttons, and sensors to create simple automated systems. Each activity taught us new skills from displaying data in the serial motor to controlling motors and detecting obstacles. We also faced challenges like wiring errors, non-working LEDs, and code problems. But through teamwork and patience, we were able to fix them and make everything work. Overall, this course helped us understand how robotics works and made us appreciate how technology can make tasks easier. It also taught us to be more patient, resourceful, and confident in solving problems through experimentation and practice.
That's all. Thank you. Have a great day.